Lesson 7 is about perimeter and area of figures that are graphed in a coordinate plane. So 7.1 will be all perimeter and 7.2 will be all area. So starting up at the top, when a polygon is graphed in a coordinate plane, you can use the distance formula to find the side lengths and eventually find the perimeter. So the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So starting with example 1, find the perimeter of rectangle ABCD with vertices at A, which is -3, -2, B, which is 0, 4, C, 4, 2, and D, 1, -4. So I think it's really helpful to draw a picture, even if you're not like necessarily graphing the rectangle itself, you're just like physically drawing out a rectangle. I think it just makes life easier. So when you name a rectangle, like rectangle ABCD, or really any shape for that matter, the vertices are ordered. So it wouldn't like randomly have, I don't know, say like 1, C, B, where it kind of mixes up the order. So that's why drawing the picture kind of helps you, I guess, visualize it a little bit more of like what side lengths you actually need to find, because we won't have to find all of them. So we'll say this is A, B, C, D, and it doesn't really matter if like these points are necessarily to scale with like where the actual coordinates are. It's just helpful for us to see like, okay, where is AB and like where is BC and so on. So if it's a rectangle, that means that these two sides are the same length and these two sides are the same length. So we don't have to find the length of all 4 sides. We just need to find either A, B, or CD, and then BC or AD. And it doesn't really matter like which ones you pick. You just kind of need to have like one long side and one short side. Okay, so I'm gonna find the distance of AB first. So we use the distance formula. Which is x2 minus x1 squared and then y2 minus y1 squared. So if we're doing A, B, doesn't really matter like which point is your point 1, which one's your point 2. I'll say that A is my point 1 and B is my point 2. So this will be like my x1, y1, and then this will be my x2, y2. So we're starting with x2 minus x1, so it'll be 0 minus -3. So 0 minus -3, and then plus y2 minus y1, so 4 minus -2. So 4 minus -2, and then squared. And then remember, anywhere you have like a double negative, like 0 minus -3, that turns into a plus. And then 4 minus -2, that turns into a plus as well. So for our next step, we'll go ahead and just kind of add the parentheses together. So 0 plus 3 is 3, still got to square it. And then 4 plus 2 is 6, so plus 6 squared. And then from there, we can add, or sorry, go ahead and like simplify the exponents. So 3 squared is 9, and then plus 6 squared is 36. And then from there, if we add those two together, 9 plus 36 is 45. And then we just want to make sure that we have like kind of our radicals in simplified radical form. So that means that if you have any like perfect square factors of your like, I guess, yeah, of the number inside the radical, that you go ahead and square root those. So what I mean by that is like 45 is 9 times 5. And we can take the square root of 9 and 5 separately, and the square root of 9 would be 3. And then the square root of 5 can't be simplified, so we would just leave that inside the radical. So the like distance between point A and point B would be 3 times the square root of 5, and that means that's also like the length of CD, because those are on opposite sides, so those will be equal. And then next we'll find either BC or AD. I'm just gonna like shrink this down so I have a little bit more space. So I'm gonna use BC. So for BC, distance equals, then we'll kind of set up our distance formula. And then I'm going to erase how each of these are labeled because we'll kind of start fresh. It doesn't matter which point is like 0.1, 0.2. I'm going to say B is 0.1 and C is 0.2. So this will be my x1, y1, and then this will be my x2, y2. So for the first part of the distance formula, sorry, I didn't mean to like zoom out so far that you couldn't see it. But for the first part of the distance formula, it's x2 minus x1. So it'll be 4 minus 0. So 4 minus 0 squared, and then plus the second part is y2 minus y1. So 2 minus 4. So 2 minus 4, and then squared. And then from there, we'll subtract inside the parentheses. So 4 minus 0, 4 squared, and then 2 minus 4 is negative 2. And then we got to square it. And then we'll square each. So 4 squared is 16. And then negative 2 squared is like negative 2 times negative 2. So it would be a positive 4. And then 16 plus 4, we can add those two together to get 20. And then same thing here, if we can simplify, we want to. So for 20, there is a perfect square factor. It's 4. Like we can think of 20 as 4 times 5, and then take the square root of both separately. So the square root of 4 would be 2, and then the square root of 5 can't be simplified. So it'd be 2 root 5. So for BC, that would be 2 times the square root of 5, and then same thing over here for AD, 2 times the square root of 5. And then when you're finding the perimeter of a rectangle, you have a couple different options. Let me shrink this down really quick. You have a couple different options. So there is like kind of a perimeter formula that you can use, and that is perimeter equals 2 times the length plus the width, since there's like 2 of the lengths and 2 of the widths. Or you can just add like all 4 sides together if you prefer that. I'll kind of show you both ways. I'll show you the adding way first. So all these numbers have like radicals, and they all have like 5 inside. So that means they're kind of like terms. So we can add them just by adding the numbers in front. So it'd be like 3 plus 2 is 5, plus 3 is 8, plus 2 is 10. So the perimeter should be like 10 times the square root of 5. And then I'll show you with the formula itself. So perimeter equals 2, and then the length we'll say is 3 root 5, doesn't really matter which one you label, length and width, and then plus the width 2 root 5, and then we'll add inside of the parentheses. So 3 root 5 plus 2 root 5, because they have the same number inside the radical, we can add them together just by adding the number in front. So 3 plus 2 is 5, and then we don't add the number inside the radical, that stays the same. It wouldn't become like root 10, it's just still root 5. And then when we're multiplying a just kind of like regular number by a number with the radical, we just have to multiply it by the number in front. We don't multiply it inside the radical. It's kind of like a gel cell. So we'll do like 2 times 5. So 2 times 5 would be 10. And then the root 5 kind of just stays exactly the same the entire time. So the perimeter of this rectangle would be 10 root 5. And then if we wanted to get like a decimal approximation, you would just have to find like the square root of 5 on a calculator and then multiply that by 10, and it ends up being about 22.4 units. So it's good to be able to kind of like see them in both. That way, if you ever have a multiple choice question that like kind of presents it in one way or the other, that you recognize each way. Okay, so one other thing I want to add really quick just about the radicals, because I know we won't see them all the time. Really the only way that like that 5 would have ever changed inside the radical is like if we were kind of like just multiplying by another radical. That's the only way to change it. So in most cases, or I guess squaring it, but you wouldn't see it unless we were like finding the area of a square. But in most cases, especially like for perimeter, that number inside the radical won't change because you're just like adding the sides. Okay, so example 2, find the perimeter of triangle ABCD with vertices at A, which is -3, -4, B, which is 5, 5, and C, which is 6, -4. Okay, so I'm going to do the same thing here, and I'm going to draw a picture. So we have a triangle. We'll say this is A, this is B, this is C. And again, it doesn't really have to be to scale or anything like that. It just kind of like is helpful to like visualize like what vertices go together. And I mean, it's a triangle, so you're gonna have all three combinations technically. But I just like being able to see it that way. Okay, so it doesn't really matter. It disappeared. It doesn't really matter where you start. You just have to start somewhere. So like I'm gonna start with A and B. Those will be like the first side that I find. Okay, so I'm gonna leave the distance formula so you can kind of see it up there, but like if we wanted to find the distance of side length AB, I'm gonna make this my 0.1 and this my 0.2, and then for my distance formula, it'll be D equals the square root of x2 minus x1, so it'll be 5 minus negative 3. So 5 minus negative 3, and then plus y2 minus y1, so 5 minus negative 4. So 5 minus negative 4, close it out, and then square it. And then we'll subtract inside the parentheses. We have some double negatives though, so any double negative turns into a plus. So that's like 5 plus 3, so 8 squared. And then 5 plus 4, so 9 squared. And then we'll square each one. So remember, you have to like square each, you can't add them together and then square after. So 8 squared is 64, and then plus 9 squared is 81. And then we'll do 64 plus 81 to get 145. So the square root of 145, it doesn't have any, or like 145 itself doesn't have any perfect square factors. So I'm just going to go ahead and take the square root of it and get like a decimal approximation. So it's about 12.04. So for the distance of AB, we'll say about 12.04, and I'm just going to go ahead and label that. So 12.04. So we found one side, we just have to kind of continue through for each side. So I'm going to find BC next. So we'll do distance between point B and point C. So for our distance formula, we got to kind of reset our points up here, but BC, I'll say this is my 0.1 and this is my 0.2. So for my distance formula, it's x1. Sorry, I went too far. But x2 minus x1, so 6 minus 5. So 6 minus 5, and then squared. And then for the other part, it's y2 minus y1, so negative 4 minus 5. So negative 4 minus 5 squared equals, and then we'll subtract each. So 6 minus 5, 1. If you want to write the 1 squared, you can. If you want to just leave it as 1 because it'll simplify that, that's fine as well. And then over here, negative 4 minus 5 is negative 9 squared. And then 1 squared is 1. Negative 9 squared is like negative 9 times negative 9, so that'd be positive 81. And then we'll add 1 plus 81 to get 82. And then honestly, like since we already converted AB, like that side to a decimal, we might as well convert this side to a decimal. So that's going to be about 9.06. So BC is approximately 9.06. And then now we just need to find one more side. And then perimeter is just like the distance around all of the sides. So we'll just add those numbers together after. So last side we have to find is AC. So we'll find the distance of AC equals, and then we got to reset our points up here. So I'll say this is my 0.1, this is my 0.2. So for x1 or x2 minus x1, it'll be 6 minus negative 3. So 6 minus negative 3 squared, and then plus y2 minus y1 will be negative 4 minus negative 4. So negative 4 minus -4, a lot of negatives, sorry, and then squared. So we'll start subtracting. So 6 minus -3 is 6 plus 3, so 9 squared. And then over here, this is kind of weird, but like -4 minus -4, you can turn the double negative into a plus if you want to, but any number minus itself is 0. Like 2 minus 2 is 0. Like 6 minus 6 is 0. So -4 minus itself, -4, is going to be 0. So plus 0 squared, and then of course that's just going to be 0. So we'll just leave it at 9 squared, which is 81. And then we can just take the square root of 81, which is 9. So that last side, AC, is going to be 9. And then now to find the perimeter, we just need to add all 3 sides together. So we'll do 12.04 plus 9.06 and then plus 9. So our total perimeter, once we add all those together, 12.04 plus 9.06 and then plus 9, sorry, I typed it in wrong and I didn't want to do it in my head and mess it up, is 30.1. So add it all together is 30.1. Okay, so between both examples for 7.1, if you need to find the perimeter, that means that you need to find the side length of all of the sides of the figure and add them together. For like perimeter of a rectangle, there is a formula. You don't have to use it no matter what. If you are finding the perimeter of an object, you can always just add all of the sides together. 7.2 is about finding the areas of figures that are graphed in a plane. So usually with area, you have to lean a little bit more on the formulas versus perimeter. So just a couple common area formulas for review. A square is area equals side length squared, like side times side. A rectangle is area equals length times width. A parallelogram is area equals base times height. And you can technically use base times height for a rectangle as well. And then for a triangle, it's area equals 1/2 base times height, or you can use base times height divided by 2 and have the same outcome. So example 1, find the area of the triangle graphed in the coordinate plane. So one thing that's really crucial about like finding the triangle is, well, we have to find base and height, but if I just draw just like kind of a generic figure here, so let's say that this is the base and like this would be the height. The height is gonna be like kind of perpendicular to the base. So we can't just say like, okay, this is the height and find this distance. Like it has to be perpendicular. So sometimes instead of like trying to create a perpendicular like segment within a triangle on a graph, it's best to check to see if any of the lines are already perpendicular. So in this figure, it looks like this may be a right angle. So we can check to see if it is by seeing if like A, B, and BC are perpendicular by finding the slope. So we just have to, before we can kind of decide, okay, what is base and height, we have to find that right angle somewhere in the triangle if it's not already given to us. So we'll find the like slope of AB first. We'll do rise over run. So the rise is, I gotta go up 1, 2, 3, 4, 5. So my rise is 5, and then my run, I'm going to the right 1, 2, 3 to go from A to B. So my run would be +3. And then we'll find the slope of BC, kind of the other part of that hopeful right angle, so BC. So for my rise from B to C, I'm going down 1, 2, 3. So my rise would be -3. And then my run, I'm going right 1, 2, 3, 4, 5. So my run would be 5. And then to check to see if that is a right angle or if those segments are perpendicular to each other, we have to have opposite reciprocal slopes. So this is 5/3 and this is -3/5. So opposite signs and reciprocals of each other. That means that like, that means that yes, like A, B, and BC are perpendicular and they form a right angle. So we've confirmed that that angle B is a right angle. So that means that now AB and BC, those can be our base and our height. And it really doesn't matter which is which because we're going to multiply them together. So it doesn't matter which is which. It just means that we have to find those segments. Those are the ones we have to find. We don't need to find AC because that's not the base or the height. Okay, so to find those segments, we need the points. So like point A is -4, so we go left 4, down 4. Point B is -1, 1, and then point C is 4, -2. So then from there, I'm going to find AB first. So for the distance between A and B, we'll say this is like our point 1 and this is our point 2. So distance formula, we can't see it anymore, but it's like x2 minus x1. So it'll be 1 minus -4. So 1 minus -4 squared. And then plus this will be y2 minus y1. So y2 is -1 minus -4. So -1 minus -4, close it out and then square it. And then now we'll subtract each. We have a bunch of double negatives. So 1 minus -4 is going to turn into 1 plus 4, so that would be 5 squared. And then -1 minus -4 turns into -1 plus 4, so that would be 3 squared. And then 5 squared is 25. Plus 3 squared is 9, and then 25 plus 9 would be 34. So this would be the square root of 34. So I'm just going to leave that as is. If you want to label it on the triangle, you can. I'm just going to kind of leave it off for now. And then now we just need to find BC, that other side. And again, we only need to find AB and BC because those are going to be the base and the height. Okay, so BC, we'll set up for our distance formula, and then it doesn't matter which ones are 0.1, 0.2. I'll say this is my 1 and this is my 2. So my first part of my distance formula will be x2 minus x1. So 4 minus -1. So 4 minus -1. And then the second part of the distance formula is y2 minus y1. So it'll be -2 minus 1. So -2 minus 1 squared. And then inside the parentheses now, 4 minus -1 turns into 4 plus 1, so that's a 5 squared. And then for my y's, -2 minus 1 is -3. And then we got to square that. And then 5 squared is 25. -3 squared means -3 times -3, so it's a positive 9. And then 25 plus 9 is 34, so the square root of 34. And 34, again, doesn't have any perfect square factors, so we can't simplify it, but I'm just going to leave it as is. And then now we have the two sides that I need. So we needed base, we needed height. Again, it doesn't really matter which one you label as which, but we're going to take each of those sides and multiply them together, and then either divide by 2 or multiply it half. So the area formula for a triangle is 1/2 base times height. So we'll do area equals 1/2, and then let's say I say the base is AB, so I'll put the square root of 34 in for B. And then let's say the height is BC, so I'll put the square root of 34 in for BC, since that was BC as, or sorry for H, because that was BC as well. So square root of 34. And then this one's a little bit funky because we ended up getting the same, I guess, length for each one. So instead of multiplying by the 1/2 first, we're going to multiply the square root of 34s first, because multiplication is cumulative, and that means that you can kind of change the order as long as they're all being multiplied. So this will be 1/2. And then those 2 square roots of 34, we could technically condense them down into the square root of 34 squared, which if you have a number that's being squared, or sorry, if you have a radical, a square root that's being squared, a square root and a squared exponent are the opposites. They're inverse operations of each other. So they just cancel each other out. because it's like saying if I were to like add 2 and subtract 2, it would do nothing. It would like make no difference. So square rooting and squaring something just wipe each other out. So it would leave us with just 1/2 times just 34, like just the number that was inside the radical. And then now I can just do 1/2 times 34, or 34 divided by 2, and that would give me 17. So this is 17. So our area is 17, and I'm just going to say units squared. So area equals 17 units squared.